So hello everyone. Today we will solve the GATE 2020 question. It is related to heat exchanger. So in this the question is saying that an orange juice flowing at 0.80 kilometer enter a counter current double pipe heat exchanger. So the main point is here is the counter current heat exchanger at 20 degrees centigrade. Entering point is 20 degrees centigrade and leaving at 72 degrees centigrade. Inlet and outlet temperature of hot water is given how much, 81 and 74 degrees centigrade, and where the specific heat of orange is mentioned 3.74 kg kilojoule per kg Kelvin, and overall heat transfer is given. So this question is asking the total heat transfer surface area. Before solving this question, we have to draw schematic diagram. So it is a here it has mentioned that it is a double pipe heat exchanger. So we will draw double pipe heat exchanger. So here is the double pipe heat exchanger. In you can see in one pipe one fluid flow and another pipe another fluid flow. It depends which we want, whether we want to heating or cooling. So usually at the center we flow the medium which we want to heat or cool. So here you can keep any one, so doesn't matter. So here it is saying, say if the through center hot water is flowing, hot water, and let's say here is flowing our orange juice. The inlet temperature is given 20 degrees centigrade and outlet is given 72 degrees centigrade, where for hot water inlet temperature is given at 81 degrees centigrade and outlet is given 74 degrees centigrade. So the hot water is losing energy and orange juice is gaining energy to raise their temperature. So and for this they have given the specific heat of orange juice and they have given overall heat transfer coefficient. So they are asking the what surface area required for this double type heat exchanger. Okay, for this question we have already drawn the schematic diagram. So the point they have given us that the mass flow rate of the juice is given, specific heat of the juice is given, and overall heat transfer is given. Here in this section two things is happening. One is the juice or we can say one hot water, this hot water is losing energy and this energy is getting transferred to the orange juice through this surface area. So it is not like that. Generally we see that there is a 2 point, this one is the hot, this one is the cold, and energy is transferring from here to here. It is not like that. Here energy is transferring throughout the area and at each point temperature is varying. So how we will solve this type of question, so we will see. Okay, so orange juice mass flow rate and specific heat is given, so we can calculate the amount of heat required to raise the temperature from 20 degrees centigrade to 72 degrees centigrade. For that, delta Q is equal to mCp delta T. Here delta Q is amount of energy required to raise the temperature from T1 to T initial to T final. It may be positive or negative when it loses the energy. Here m is the mass of that matter, Cp is the specific heat, and delta T is the temperature difference. the based on given data we will calculate the delta Q, and here M is in given 0.8 kg per second. So here mass, it is not given mass, here mass flow rate is given, so it doesn't matter, you can write here mass flow rate. So here we will get kilojoule per second. Specific heat is given 3.74 kilojoule per kg Kelvin, and delta T is 74 minus, sorry, 72 minus 20, it will be 52 degree centigrade, or we can write the Kelvin. So Kelvin, kg will get cancelled, and this value will be 155.58 kilojoule per second. So this much energy is required for orange juice to raise the temperature 20 to 72 degrees centigrade. That means this much energy will, from where this orange juice will get the energy, from the hot water, but we don't know the specific heat of hot water, so we cannot use this formula because we don't know mass transfer of hot water or Cp of hot water, but we know the delta T. But we know that the whatever the hot energy we lose by hot water will get transferred to this surface. So for that the equation is energy transfer UA delta T. For any surface we write the energy transfer equation is UA delta T, where U is representing here overall heat transfer equation. A is the area through which heat is transferring. So why don't we use the HA delta T this and KA delta T by X. So these two equation is also heat transferring equation. So here both convection and conduction occurs through the pipe media. From pipe media to the surrounding media, convection occur and conduction occur, but by merging two both we will get the U. So already we have this question gave us the U value, so we don't have to consider these 2 points. Okay, here the major problem come that when we talk about the delta T, it is a difference between hot and cold point, hot and cold point temperature difference. But when we say that what is the temperature difference between hot and cold, what you will say, 81 minus 72? No. What you will say, 74 minus 72? No. We can't say that what is the temperature difference, because at each point the hot water temperature difference and at each point cold orange juice temperature is different. So we cannot simply subtract the temperature of this or temperature of orange juice. For that one concept came is LMTD. To calculate the exact approx temperature difference between hot and cold fluid. So how we will calculate the LMTD? Let's see. Okay, so here we will see the LMTD, that means log mean temperature difference. There are two cases for LMTD. One is the co-current, another one is the counter current. X-axis represent the temperature, this one is the time, this one is the time, this one is also temperature. Okay, at the initial stage, in co-current, that means both flow in the same direction, hot and cold fluid. So somewhere the temperature is like this. As the time proceed, the hot water temperature will reduce and approach toward the cold water, and cold water temperature will increase and approach toward the hot water, but it won't touch. So this one will be the TH1, this one will be the TH2, this will be the TC1, this one will be the TC2. This one is for the co-current, and in counter current, this one is the TH1, this one is the TC1. As time proceed, hot water temperature will lower down and cold water temperature will increase. So it will become TH2, this will be the TC2. So without going further on this, the formula for LMTD is theta 2 minus theta 1 divided by ln theta 2 theta 1. What is theta 2? Theta 2 is the temperature difference. So from here, the temperature difference between these 2 points and these 2 points will be theta 1 and theta 2, and here also theta 1 and theta 2. You can assume any one. Here the temperature theta, suppose we call this one theta 1, we call this one theta 2. So what will be the theta 1? TH1 minus TH2. What will be the theta 2? TH2 minus TC2. Sorry, TH1 minus TC1 for the theta 1 and theta 2. For here, what will be the theta 1? TH1 minus TC2, and theta 2 will be TH2 minus TC2. So we can take any of these theta 1 and theta 2, or we can also write that theta 1 minus theta 2 divided by ln theta 1 by theta 2. Remember that what will come first, it will be always on the top side of the log. So this is a basic thing about the LMTD. Using this equation, we will calculate the this LMTD will give the log mean temperature difference between any two, either it will be co-current or counter current. In our case, it is a counter current, so we will calculate the LMTD value for that counter current. Let me draw the graph for counter current. So here hot water temperature reduce, hot water temperature 81 to 74 degrees centigrade, and cold water temperature increases from 20 degrees centigrade to somewhere 72 degrees centigrade. This point should be the lower than this point, but doesn't matter. We have to calculate LMTD. So here our theta 1 is how much? 81 minus 72. It will be the 9 degrees centigrade, and theta 2 will be 74 minus 20. So it will be 54 degrees centigrade. So we will calculate the LMTD. LMTD, I told you theta 2 minus theta 1. Here theta 2 is on top, so in box also it will come upper side. Easy to remember. Theta 2 value is 54 minus 9 ln 54 divided by 9. If you calculate using, the value will be 25.14 degrees centigrade or Kelvin. This is the log mean temperature difference. Now we can calculate the amount of energy transferred. So UA delta T LM TD. So the value of U is given 424. Okay, value is given 492. Area we have to calculate LMTD. How much we got? 25.14. Okay, so let me write the unit also. 492 watt per meter square Kelvin. So here the Kelvin get cancelled. So it will, so this much, so it will become 492 into 25.14 watt or joule per second. Okay, so as we know that the amount of energy gained by this will be equal to the amount of energy transfer. So transfer energy will be equal to gain energy. So the how much transferred energy? 492 multiplied by 25.74. Sorry, A is Mr. A. This much watt energy has been transferred and how much energy was gained, and that energy will be gained by the juice, that will be equal to 155.58 kilowatt. So we will convert, so here the area will be 155 into kilo, we will convert 10 to the power 3 watt divided by 492 multiplied by 25.74 watt, and here will be meter square. Something we missed. Okay, so this will go upper side, meter square, watt will get cancelled, and the value for this we will get 12.578 meter square. So this much area we required for double pipe heat exchanger to transfer the energy from hot water to orange juice. So our next question, which was asked in GATE 2004, this I will give you as assignment. You do this one by your own. Why? Because this is same like previous question, but the difference is there is a heat loss. So now you have to consider the heat loss also. So I will give you some hint. So what you have to do is the whatever the like hot medium loses the heat energy, the heat energy loss by hot water will be equal to heat, some energy will be transferred and some will be the loss. You have to keep this thing in mind. So based on that, what the hot water will lose the energy and some will get lost into the surrounding, and some will be the transfer, which will absorbed by the cold fluid. And let's see how you solve, and given is 10%. So first question they are asking the outlet temperature of cooling water. Okay, and next question they ask the NTU. So we will talk this NTU in details in the next session. Thank you. If you have any query, you may write it in comment, or if you have any question separate from this, so you may write on the comment box. So I will try to solve that one in next session. Thank you.